Okay, so um, welcome back. Good to see significant interest being retained here. So yesterday I talked at a very high level about some of the ways in which Java, the roles Java plays vis-a-vis AnyLogic. And today we're going to be going into some of the nitty-gritty associated with Java and AnyLogic. This may involve some hands-on work, but a lot of it will be teaching some core concepts relating to values and expressions, these sort of formulas we put into it. As time allows, we may also go on and cover statements, multiple types of statements today, and I'm hoping we will. So within this context, there are frequent needs within the AnyLogic user interface for putting in place formulas that give values. We saw that at many points within the context of today's model, but we've also seen it in other models. So, for example, if we went to a person, we saw that associated with, for example, this recovery point, we had a timeout, and we gave a expression here. We gave a formula that told it where to get the value to use for the timeout. Do you remember that? Similarly, we here had given it a value for this rate. Now, particularly with the first of those, it's worth noting that we could have put there an explicit value. We could have put there 100. Dylan, would you mind getting a couple more chairs in here just in case a couple more people want to come in? Merlin suggested, he said stealing from 360. I don't know where 360 is. But 311, I think, has quite a few. But we'll just have to move them back. Okay? Thanks very much, folks. Okay. Oh, that's great. We're getting some more chairs here, even as we speak. So this is a quantity that actually turns into a value. It needs a value here for the timeout, and this is something that gives a value. And values in AnyLogic in general are single quantities that cannot be further evaluated. They're a single thing like a number, 3.14159 or 2. Or it could be a quote, a string. Or it could be a reference to a particular person. These values are needed at many places in AnyLogic. We've just seen them here. They're also needed, of course, in main, like in the population size up here, up at the top, the population size or the value for income to be used for each person, value to be used for X and Y, and the value over which we wish to take an average here for this average. So values are quite key to AnyLogic's to interfacing with AnyLogic, and much of what you tell AnyLogic about are things that deliver a value, that provide a value. The values they provide, as I said, sometimes are integers, sometimes they're floating point numbers, sometimes they're characters, sometimes they're true or false. Something's true, something's false. So where did we see something that was true and false during our example today? Anyone remember? Or do we have to give it something that, I'm sorry? Yeah, so there was, within the context of population statistics, for example, we had here count infective, and we needed to give it something here that for a given person item would tell whether that person was infective or not. So that returned true if it was the case, and false otherwise, and it would count the number for whom this was true. Remember that? Okay, so values come in many different sorts. One of the most important types of values that we'll be concentrating on possibly today, possibly tomorrow, is this issue of values that are references to objects, okay? References to a particular person. I'm pointing at a person. I'm pointing at Iden. It's a reference to Iden. It's a reference to Maine, a reference to a string, to a simulation, or what have you. So we have these values that are different quantities. I'd maybe, just to make sure everyone knows, maybe you could go around a couple of rooms and just let people know the Java tutorial is underway. Yeah. Now, where do these values come from? Well, some of the values are put in as hard-coded entities. They're put in directly in. So we might say the initial number of agents here was 100, right? We put it in as a number. But for the most part, when we wish to specify value, we don't just put in a number. We put in something that denotes a number, that, as we say, evaluates to a number. It turns into a number. It becomes a number as its value is determined, or any of the other quantities. So we'll say population size, and that's a variable. It's down here. Population size. Excuse me, it's a parameter. Population size, and that turns into a number. This is another thing we put. It's another thing that evaluates to a value, to a specific value. For each given person, their income is determined by drawing a value from a log normal distribution. Okay? Try to get some more seats in here. So we're drawing a value from the log normal distribution. So these things, in general, are called expressions. You could think of them as a formula. Okay? They're a formula that determines a value. It evaluates to a value, as we say. It's like us when we were in grade school adding up 3 plus 4 and getting 7. And for years, you've been writing expressions, in algebra, using them in Excel and calculators. You say in Excel, cell C1 is equal to cell B1 plus cell A1, right? Very familiar type of thing. So you should be very comfortable with the idea of putting in formulas. And these are examples of some formulas here. So we might put in a formula 2 times 5, and that will evaluate to 10. Put in 2 divided by 5, and what will that evaluate to? 0. For that rule we saw earlier. 5 goes into 2 as an integer 0 times, so it turns it into 0, which is, for many people, counterintuitive, but because they're integers. If you made it 2 divided by 5.0, it would turn instead into 0.4. 1.0 divided by 3 turns into roughly 0.3333, etc. And depending on the values of A, B, and C, evaluate. Now, some expressions are more articulated. This get connected agent I name. It's asking for the name of the ith connected agent for myself. This. Or a double precision rendering of 2 divided by 5 will be 0.4. So we convert 2 into a double. Now, in the process of computing a value, sometimes it does things which can change the current situation. It may call a method like getConnectedAgent, and that might actually change something. So it's not that we are purely always determining just a value in it and there's nothing being changed. Sometimes things are changed. But for the most part, we distinguish things that compute values, that calculate values, Java expressions, from things that change anything. There's commands that change, do this, and then there's things that just compute values. And in general practice, it's kind of nice to have those separated. Okay, so here's a couple of common Java expressions. Many of them are literals. 3.5, 1, my string. This is actually a Java expression that denotes an array consisting of, kind of like a vector consisting of 1, 2.71, 3.14, and 0. A final value is null, which means not referring to any particular object. It would be referring to some object, but it's referring to none. It's the decided value referring to none. We may have a Java expression that's a comparison. A is greater than B. A is less than or equal to B. Remember this one? Some people asked about it. A doubles equals B. What does that mean? Yeah, it's asking, is A equal to B? In contrast to this, which would be saying, make A equal to the value of A equal to the value of B. Have A now hold a value that's equal to the value currently in B. Okay? There are times where it's a little bit confusing. We might write, in some cases, A plus B as a mathematical quantity, but plus sometimes means other things. It means string concatenation. Do you remember where we saw that today? Remember where we saw that? Remember it was in the on-click? Yeah, it was the trace ln. Man, you folks are good. Trace ln. Remember it was this guy here, but we couldn't go just click on it. We had to go down like this, and we had to go, and I think it was in advanced here. Oh no, it was sorry. I misspeak. It was this guy here, right there. All right? Now, so there are times it's a little bit confusing. Certain operators sometimes mean one thing, sometimes mean something else. It instead of plus for strings mean to concatenate them, to append them. There's a ternary operator, which is useful. It's kind of like an if statement, but it's an if expression. And it says, is one thing true? If so, is this true? If so, use the value A, otherwise use the value B. So it picks either A or B, depending on whether this is true. But then there's some additional types of operators that are a little bit more involved. One is a dereferencing operator. We've seen this a lot. I just kind of glossed over it. This dot income. Remember that? Or self dot income. Remember that? Item dot income. What's that dot? Well, I commented informally. It's kind of like an apostrophe S. It's like items B. A's B. The point is, if we have a reference A to an object, maybe it's a reference to a person. It's a reference to Aiden. I can say Aiden's hair. Aiden dot hair, and it will refer to his hair. Aiden's income. It will refer to his income. So here we have a reference to some particular object, and maybe it's to a person, and we can ask for this sort of property, field, or for that matter, a method of that thing. We'll be seeing more of these things. But we saw it just in the previous slide with something like this. Here, I'm saying, hey, call this method, call that method on this, passing it this piece of information, which agent to retrieve. And once I've got that, I ask for that person's name, that agent's name. So if this, I ask, hey, this, get my connected agent number I, starting at 0, 1, 2, 3. So maybe it's connected agent 3. So that's the 0, 1, 2, 3rd. So that's the 4th overall agent because it starts from 0. It refers to a particular person. Maybe that person is Aiden. Then I ask Aiden's name. What's Aiden's name? So this dot, if the thing before the dot is basically a reference to some object. It's referring to something, to Aiden, or it's referring to Cheryl, or it's referring to Roe, or something like that. And then we're going to ask, okay, who's their connected person? And that returns a reference to a different person, and we're going to ask that person's name. So this dot is kind of used to, it's called the dereferencing operator. It's asking for something about some field of A or some method of A. Yes, question?
Am I understanding correctly that when you use item dot self dot or and so forth, that I understand that in AnyLogic you can hover and it'll kind of prompt you for which to use. But is that a reference to whether you're referring to this in, is that the page you're on? In other words, is that if you're on name versus if you're on an agent page?
Not so.
To the screen that you're on? Or if you're pulling from another screen versus the screen you're on, is that where you distinguish?
No, it's associated with the screen, but it's not dependent on the screen. The screen is kind of a useful cue. It's a useful heuristic to see what it means. But basically, things inside a person that you're writing inside a person will, as a general rule, the things inside a person will be within code that runs where they're running associated with a particular person. So maybe the state chart's operating in the context of a particular person. So if we say, for example, if we print out here, if I printed out, here I printed out my income. Or look at this. I could say this dot. I actually just omitted it here, but it's really this dot color. That's my color. And the reason it's a person, it's because it's inside the person class. Yes, this has to be showing, but it would be just as true if this weren't visible and I were accessing it through here. This is still referring to person. It's this because it's inside of person. This code is running inside of person, and this refers to kind of things inside of the current object. Yeah.
Talking about something that's running over the entire,
Yeah, this main dot is a reference to main, the single main thing. Yeah, and this is not a Java thing. This is an AnyLogic thing that, in other words, it makes this thing called main available so you can easily refer to it. But it's a reference to main.
So then there's item and self as well, and are those interchangeable at all with this? I mean, this is very specific on main, and then we have item and self, and I'm trying to understand.
So maybe I could come back to this because we're going to have a whole lecture on these sort of things, sort of reference to that. And I think that would be the most natural time to try to deal with that, if I could. But for the purpose of this lecture, main, the thing that refers to main, evaluates to a value, which is a reference to a particular main. It's the only main around. And this refers to me, which in the context of a person is a particular person. Right. Okay. Now, you should know that expressions, somewhat confusingly, there are expressions that you can use that change things. Calling off to a method changes things. A++ changes things. It gets the value of A, and it uses that. It's going to evaluate. So if A is 3, and I say A++, the value of that is 3, but it changes A at the same time to become 4 now. So we've seen this once before. We saw it yesterday when I looped through this thing, and I said I++, and then I thought the better of it, and I made it I equals I plus 1. The point is that sometimes we do use this as a value, as an expression to get a value from it. It's not good practice because it's also changing things, but it does happen. And then a method call, like I can ask get main. Okay.
Just very quick.
Yeah.
Plus A.
Mm-hmm. Plus A or plus A. Yeah. No. No. plus A. I feel, for the fourth time today, I feel ashamed. I feel ashamed. This goes back to around 1971. It was a simpler world in some ways. And A++. So this is an expression that evaluates to value. Expressions evaluate to value. That's their job in life. They produce a value. But if you want to be clever, too clever for your own good, you can actually, when you're calling it, or when you're doing this, you can actually change something too. I give you a value, and at the same time, it changed something. So here, I'm giving the value of A, but I increment it. You get, if A is 3 right now, and you ask me, and I say A++, the value of that is 3. But after I get the value, A has itself become 4. Just the value I got back was 3. Plus A, it actually evaluates to 4 because it actually increments it before giving me the value. You see me twitching. I'm sorry. A plus equals to 2 will actually increase A by 2 and return the resulting value. So if A is 3, it'll actually turn it into 5 and give you 5 back. Okay. So anyway, I don't tend to rely on these things. I might use these quite a bit, but I don't use them to get the current value of them because I don't consider it safe. It's changing things out from under me. Why would I do that? If I have it by itself, and I don't count on its value. Okay. So where do we see this? Does anyone remember this? A and B? Where do we see that? Well, we saw it in our model, right? Did we not? We did. We saw it here, right? Yeah, it was right counting this. Remember that? We said count people for whom this is true. Their income is less than 400 and they're in this state. Remember that thing? Someone once told me, and I don't happen to agree with this sentiment. Someone once told me, teaching is the art of lying artfully. And I've got a bit of fessing to do. No, the truth is, I've been basically telling you the right thing, but I did simplify one thing. This person not infective, that's a little bit of a special thing. It's actually ask about infective the person class, not of a specific person, and that's why it's person, not a particular person, not item, not infective. It's this thing of the person class, the infective state, the name of and that's shared between all people. So we're asking it a person. So that's a little bit of a different use of dereferencing. So you can have A and B, if this thing is true and that thing is true. A or B, if this thing is true or that is true. This means not, meaning if you say it's not, the person is not in this state, right? I would say like count, I don't know, I could add one of these, right? Count non-infective. How would I write that? Anyone tell me? How would I write that? Okay? Yeah, but you'd have to use this not item dot in state, and then you'd have to say person dot infective. That's what that would be. In other words, I'm counting the number of people who are not infected. So I need this exclamation point in front. I know you must think we're a weird lot to use that, but that's what it means. So if we want to know, is, for example, my X location in a certain range, this would test if it's between what? 0 and 500. This, by contrast, would test if it's not within that range, if it's outside of that range. Here's another type of expression, A of 20. This square bracket means it's actually treated as a vector. So look up the 20th item, actually 21st, because it starts at 0. 21st item within this. So it's kind of like A is a vector. It's actually called an array. Here we go. And, maybe it has in it values that are, itself 0, 2, 4, 6. I'm just making up values that are in it, but 12, etc. And we're looking up the 21st item. If it were A of 0, it would give us back 0. It will give us back 0. A of 2 will be giving us, I'll use this instead of double equals. A of 2 would be giving us 2. A of 3, excuse me, what am I doing? Sorry, I'm out to lunch. Could someone pass that down? Yeah, yeah. A of, what I meant is A of 1. Sorry, long day. Okay, so this is 2. This guy, 0, 1, 2, is 4, etc. Okay? Yeah. So we're looking up that item within this, where this is the index we're seeking, and it's based, it's starting at 0. Sure. Sure, we'll use it quite a bit. We'll look up, for example, the empirical data for the current time.
So if you're drawing from a CSV file and you're saying, look
Yep.
up the
Yep.
person
Yep.
and generate from that.
Yeah, we could do that. You could look up, you draw in data from the CSV file about the characteristics of the ages of different population members, and you're instantiating each successive person's age or income. Let's suppose here, for this, we wanted to draw incomes from a database, and we drew it in, and we had a, income vector, and we wish to look up the income of the current person whose index is given by index. This would be given, maybe we read income vector in at the very start of the model when it was just kind of starting up, and now for each person's income and term, we're determining their income as from that vector. Is that helpful? Yeah. Great questions. Now, another common expression, common operator, is to call an expression, call a function. Pass this with 2 pieces of information, 2 so-called arguments, 2 so-called parameters. It needs to do its job. In computer science, we tend to use the term arguments or parameters, and they have a slight difference in meaning. But we'll talk about passing these as parameters to F, 2 and 3, or we'll talk about passing these as arguments to F. They're used in both ways. Is that term argument, is that used outside of computer science to mean the things you pass? I've just been, it's been so long since I remember what the terminology is. I don't remember if that's common terminology to say I pass it as an argument. No? Okay. For us, it's like maybe the sucking reflex is more basic or something, but that's like one of the most basic things. So we say, okay, pass it as an argument. Okay, yeah, fine. Okay, for strings, this is concatenate, right? Okay. Okay, so let's talk about Java expressions. How do you read these? How do you kind of parse them? Because sometimes they look fearsome. I will tell you something. I really dislike long, complicated expressions. I really dislike them. They are cause for confusion. They are cause for bugs. They are cause for turning people off, for making them give up. They can understand them all. But teaching aside, I really dislike looking because I will often look at them when I am tired. I'll say, oh man, okay, I got to read that thing. But there is a way you read them in a structured way. So here we have a long expression. There it is. It sits before us in all its fulsomeness. So how to read this expression? How do you turn this into something meaningful? Well, you read it from left to right, inside to out. Okay? So we start with A. What sort of thing is A? If we have A dot, what is it? It's a reference to something. It's referring to some object. Maybe it's a person. Indeed, it is a person here. So we have some reference, and we ask that reference, okay, get me your connected agent. Which agent? Number i's. Again, numbered from 0. 0, 1, 2. Maybe I is 4. In this case, it's their 5th connected agent. 0, 1, 2, 3, 4. Right? 0, 1, 2, 3, 4. Their 5th connected agent. Okay, great. So we get back. That gives us back a reference to an agent. Then we ask, what's that agent's name? What does that give us back? That gives us back a reference to a string that gives their name. That string is Iden. Okay? And then we ask for the length of that string. So we've got all these dots, but each dot is asking something different for for some information. This first dot is a reference to a person, and from calling this method on that person, we get a reference to a different person, to Aiden. We ask him for his name, and it gives back a reference to a string, which is his name, and we ask for that length. So they're kind of commonly strung together in that way. In fact, this is called fluent style of writing expressions, and it's very, very common these days. You can just chain them together and get a nice long expression that kind of computes something. But the more things you pack into there, the more confusing it is. So generally, you don't try to pack more than, one or two of these folks at a time. Okay. Any questions about that? Yeah.
Yeah, maybe a dumb question, but what is a string, or how can I get a concept?
A string?
Yeah.
So, great question. Could anyone pass down that? Okay. I thought there was also a little marker there. Oh, yeah. Thanks. So a string is just a sequence of characters. So a string might be foo. It might be a string. A string might be Aiden. A string might be.
Is this any sequence of characters?
It's any sequence of characters. Luz Maria. Okay, I misspelled it, I think, probably. But okay, something like that. It might even have accents in it. I don't know. Sorry, I don't know where the accents are, if there are any. There's not an accent there. I'm confident about that. This string could be in another language. I don't know. Could have a big person. Something like that. These strings can have lots of things. They can have spaces, no problem. They can have weird symbols in it. It could be an email address. It could be a string of weird characters. Yeah, sure. It's a sequence of characters. That's what it is. It's a reference to a sequence of characters. That's very common. Remember that thing I passed? At one point I said, "You're infected. I'm going to expose you." Remember that? And I passed a string as exposed. Exclamation point. That's a string. Sequence of characters. This is a reference to a sequence of characters. If you really want to know what's going on under the surface, this actually turns into an array of characters, just like this one. The first character is E. Second character is X. Third character is P. O, S, E, D. Exclamation point. And then, for many languages, at the end would be something called the null character to terminate it. Boom. But you don't have to worry about that, but that's how it's stored for many languages. Okay. Anyway, that's a sequence of characters. Is that helpful?
Yeah, just because when you say give name, you mentioned it's a string, then I'm like, I wasn't clear, but now I know it's just.
Yeah, it gives me a reference to this thing.
Yeah.
And then I could ask for this thing's length. I could say 1, 2, 3, 4, 5, and so on, and it would return the length, right? 8. Okay. Okay. Now, in the code that we've written, we created yesterday a model. This was this hybrid budding model. Do you remember this? I know it may have scared you. Do you remember this one? Okay, and we created some code. Watch this. I'm gonna. Remember this code? How could you forget? Maybe it was a traumatic experience and it's blotted out. Do you remember this code? Here's something that I did, and I kind of waved it off, as is my wont, as I am wont. This is what's called a variable. It's just a name for a value. It holds a value, and it's a nice name for it. We use it to sort of hold a value, and we give it a nice name so we can refer to it, and maybe it will be changed later, but a lot of times it's never changed again. It's just a nice name for that value. The count of agents to be created. It's a value, right? Where did that value come from? From whence did that come? It came from this expression right here. The one that's right here, right? That's where it came from. We computed this expression, we called it a nice name. Actually stored it in this location. We never updated that again. We just were using that. Where this is used, we could have put this expression. Could have put it there. Could have put it there. But it's nice to kind of refer to it once. It only has to figure this out one time, and it gives a nice name to it. Gives a nice name to that value that's computed via this, and it stores it there, and then we refer to it. So this is called a variable. Now, a lot of the variables we included in our models were things we put in explicitly. Those little v's, do you remember that? And we could have done this for this guy, but because this guy only lives within this function, I know, it must think that's weird. We computer scientists like to talk about variables living in places and so on, and that's just where we are. This one lives on the stack. So this lives only in this function. It only needs to be seen in this function to be used in this function. So we just declare it right here. This is called a declaration. It's saying this is an integer. We're going to use this name to denote an integer. And it's a location for it, but it stores a value, and then we're going to use that value at several points here, and then we'll be done with it, and we don't have to worry about it again. This is a nice name. It's a variable, and a variable contains this value. It contains a value. Variables are associated with types. What was the type of this variable? Anyone? It's an integer. It's an int. It's an integer. Here, where's another integer here? Right there, right? Int I. See this? Use your newfound knowledge of Java. What could this be replaced by? I++. And in that case, we're not actually using I at that moment. We're just incrementing. We're just creating. And that's a really, okay, at least to my eyes, it seems kind of short and sweet. It's just very clear, I'm incrementing I. Sweet. Whereas if I see this, I kind of have to look, if I see the thing that I replaced, if I see this, I kind of, okay, is it the same thing over there, and it's by 1? Okay, now I understand it. This actually tells me that immediately. But I recognize for newcomers, it's not that easy. Okay, so let's talk about it. So variables contain values. And we declare a variable. This is called declaring a variable. I know that's really confusing. But again, that's the sort of standard term for it. We declare a variable. We declare the variable I. In other words, we state our intention to have a variable I. Let there be a variable I. Okay. And so we indicate its name and its type. So I said, int count agents be created. I'm saying, let there be a variable called count agents be created that is an integer. Let there be a variable I that's an integer. Yes.
When you declare that variable, it can be any name you give it. You can just put any name you want to choose to give for the expression that is in front after the import.
Say this again.
Yeah. So the count agents.
Yeah, we could give it.
Any name you want.
Mumble. We could not any name. Like it would throw a fit. Watch this. You want to see what will happen? I'll make it throw a fit. Okay. Would you like to see that? Okay. Let's go see that. Okay. Right now this is a happy camper. Right. Build completed successfully. I'm gonna make it a most unhappy camper. Is that okay? Watch this. Watch this. Okay? Count agents to be created. I'm going to put a space in the middle. Okay? All I'm introducing is a little space. Give me a little room. You know? And watch this. It is a very unhappy camper now. It says syntax error. Insert semicolon to complete local variable declaration statement. It doesn't know what makes it. Syntax error basically means it doesn't understand your grammar. It doesn't understand what you're trying to say there. What you're trying to say is confusing. It's confusing to it. In fact, you can't have that. You can't have a space there. you can have some things that look like spaces. You can have an underbar. An underbar is actually eligible, but if you put an underbar there, it would have to be put here too, it would have to be put here, wherever it refers to it. I could not put, an exclamation point, but it'll think this is one thing, this is another, and it will throw a most unhappy fit. Watch this. Boom. Boom. Doesn't know syntax error on this, doesn't know what to do. And if you double click on these things, it'll take you to the offending line. It says, I don't know what to do with this. I don't know what you're saying. You're saying nonsense to me. And so I'm going to say, so it can't be anything like there in a string. Those things inside quotes, those it just takes whatever you want to put inside those quotes is fine. Sort of. You can't put another double quote inside a quote without putting something that tells it it's a special character, but that you really want to put a double quote inside of it. But the point is that you can have alphanumerics here, you can have underbars, you have alphanumerics and underbars, and maybe there's something I'm forgetting, but alphanumerics and underbars. So you could have, this, that's fine. You can have underbars, but you can't have spaces. You can't have lots of other things that will confuse it. You can't have parentheses, etc. Is that helpful? Okay. So variables. These are sort of places that a value can live. That there's a value associated with the variable. And what's inside so the variable denotes a location and it stores a value. And that can be updated over time. We may want to update that. Where within this code, ladies and gentlemen, where within this code did we update a variable? Where did we have a variable that has a name? You may not think it's nice. But over time, that name holds different values. Where is that? I++. Yeah, this I is changing values. It starts as 0, and then it gets successively larger with each iteration of this loop. Just like that. This guy, by contrast, is just a name for this value. It's just used from then on. It's not updated. A thing of beauty. But this one is actually updated. It's updated on an ongoing basis. So variables can be updated like this. So we can have variables that hold values of all the different sorts of that are possible for values. So for a value, I said earlier, it can hold many sorts of things. Integers, floating point values, characters, Booleans, so true and false things. It can hold a reference to a so-called instance of a class, a particular color. Where do we have a variable that denoted a color? Does anyone remember? How could you forget? Yeah, okay. I don't want to start another War of 1812, okay? But okay, you win. Just stop invading us. Okay, so it's color, right? That's a value that denoted a color. Was that changing over time? Yeah, you bet it changed over time. It changed here, right? So changed to green, changed to red. So in general, these things can change, and they can refer to objects, particular colors, for example, particular people. Those are objects, they're instances of class, particular sort of, not describe personhood, it's a particular person, Iden. Okay? I'm not going to go into this. This is too complex, but we can say something like their age is 0, their color equals green. Right? You'll notice that what can be on the left-hand side is not just the name of a variable. It can be a whole, what's called L value. It can be a whole expression here. This dot get main dot population size equals 100. That means population size inside of main is equal to 100. We can do that. As long as this refers to something that can hold a value, we can refer to it. Yeah. So Java variables can be found in many different contexts. These variables have different visibility associated with them. This variable here that we saw within this context was only visible within this code. The variable, by contrast, that we have here or here in the stock and flow, or this variable that's in person, this is visible throughout person. Anywhere in person, you could write code in any number of different places here. It will see this variable. Color. Okay. Okay. There's many types of those variables. Tomorrow, we're going to be seeing a new type of variable called a formal parameter, which when we declare a function. Boy, am I tempted to show that to you now. Oh boy. But I think we'll hold off for a little bit. I ponder the possibilities. We can also have fields. These are variables associated with objects. But then there are some class variables associated with a class, not a particular person. Where did we see that? Not 15 minutes ago. Actually, colors associated with each person has a different particular color. Each person does. But what things did we refer to that it was a property of person? We actually said person dot. Well, there's no ethnicity represented in this model, but we actually said person. I know what you may be thinking about that, but where did we say person dot? Do you remember that? It was I stood in front of you and talked about it, and yeah, it was count infective. Do you remember this? Do you remember this? This is a variable of person. It doesn't vary. This is denoting what? It's denoting the state. It's just a name for the state. Someone can be an infective. That name doesn't have to vary on a per person basis. In other words, we have the same way of saying infective for myself and for Cheryl. Even though we're different people, we have the same designation of infective. We're in the infective state. It's like we have the same code for it. Right? The same standardized way of saying I'm in the infective state. Same label for it. Same code for it. And that's what that person dot infective means. It's referring to the name and value for infective state for person. That's a variable associated with a class. Okay. The notion of variable scope, you can only see a variable for certain places, and variables disappear. Okay, I think I'm going to, this is all true stuff. I don't think I need to go into it. Okay, let's talk about variables and expressions, though, and assignment expressions. So if you have a variable called A, we can write expressions like this. A equals B. What does that do? Suppose B is a value, 3. What does that do to A? It sets its value to 3. How about A plus equals B? What does that do? If B is 3, what does this do? It increases A by 3. It adds 3 to A. A times equals B. This multiplies A by 3. In other words, A equals A times 3. That's what this means. This is A equals A plus B. This is A equals A divided by B. This is A equals what? A minus B. What is this? A is incremented. A becomes 1 bigger than its previous value, and we use the value of it that was before we increment it. This, A becomes 1 bigger, but we use the value after we incremented it if we depend on that value. Now, often you just see these things on a line by themselves. It doesn't matter what the value is returned by. The point is it's increment. It's incremented by 1. It's decremented by 1. And it doesn't matter what order it's in because we don't use the value from it. Okay. Right. So these are useful shorthands. And they are they're quite common. If you go and you look at AnyLogic's code that it's generated, which I would offer caution about, which I rarely do, or if you look at example models provided by this bootcamp, you will find some cases of this for sure. You will find some cases like this with great confidence, but they unpack in a very regular way. Okay? So this just turns into this. So I'm just warning you that if you see these kind of things which are very confusing, they actually turn into something very sensible. It's just they're a little bit obscure because they're not really familiar. Okay. Now, just because we could do that with a variable, A++, we could also do it with an array, like a reference to a member of an array. So we could say A of 20++. This thing is the 21st item of that array, and we could say add 1 to it. Make it 1 bigger than it was. We could say, hey, if P is a reference to a person, we get their connected neighbor, number 3, 0, 1, 2, and then we take their income and we double it. They're a lucky person. Income just got doubled. Okay. Right. So, okay, yeah. So now we're coming to the place that will stretch you a little bit more. Okay. So here's Iden. Iden's an agent, right? That's Iden, and he has a certain income. He has a certain, he has a certain state with respect to his SIR state chart or what have you. Maybe he has a certain age, right? Certain birth weight, whatever, right? He has some characteristics. Here's Iden. Okay? I may have a reference to Iden that's stored in a variable. This variable is called A, and it refers to Iden. There may be other variables. There's one called B that also refers to Iden. Kind of like, I don't know, like people call me Nathaniel, they call me Nate, they call me Nathan, they call me Nat. Not with a G. And they all refer to me, right? They all refer to me. So we could have references to an existing thing, a particular person, say, in our model. So we can have a reference, for example, to A, refers to Iden, maybe, and we can set Iden's mother to be a particular person in the population. This is a reference to some particular person. Or we could set Iden's mother to equal the third person in the population. Well, let's be clear about what's being done here, okay? So what's going on here? So at the very start, we might have something like this. Here's Iden, a reference to Iden. Well, okay, his age is 4, which isn't so appropriate. His mother is not known right now, and he's male. Okay. And M is referring to a different person, someone who's 40 years old, and has no recorded mother, and is male is false here. Now, maybe I'm in Maine, and Maine contains a population that is represented like this. This is the 0th person in the population, the first, the second, the third. Put it this way. This is a person at index 0, index 1, index 2, index 3. Okay, so this is what we start with. A is referring to Iden. After this, what happens? Well, now Iden's mother points to this person. M was already referring to this person, and we said Iden's mother should now refer to the same value as M. So initially it was null, it didn't have any particular person to whom it referred, and now after this, it's referring to whatever M refers to. Does that make sense? Okay. And now, next, if I do this, A.mother refers to the person at index 2. Now, Iden's mother refers to this person, index 0, 1, 2, in the population, whoever this person is. But notice M doesn't change. M is still referring to this one. We didn't change M. All we changed is what Iden's mother field refers to. It refers to this one here. So M is still referring to this person, whoever she is. Does that make sense? Okay, pardon me. I'm teaching. I'll call you back. Oh man. Okay, I didn't know about the asbestos. Okay. I'll call back. That doesn't sound good. Thanks. Bye-bye. Sorry, we're undergoing renovations. It's never good to hear we have asbestos. Okay. Quebec seems to still like it in parts of Quebec, but certain parts of Quebec. But it's unfortunate here. So this is an update. So here, an important class of values I'm trying to communicate are references to objects. One object would be Iden. Another object would be this person here. Your model is chock-a-block full of references to objects. Some of those objects are to people. Some of those objects are to strings. Some of those objects are to main. We have lots and lots of places we refer to objects in the model. That's an important type of value, just as important as a number, 3, an integer, or a double precision value, 3.14159. It's just as important as specific characters as strings, are references to these objects that actually could be of strings, could be of people, could be of main. Lots and lots of places in the model where it refers to them. So those are some comments on values. Are you comfortable with that notion? Your model, I would say as a general rule, most of the places you put Java into your model are to compute values. Most of the things, if you go and you add up the number of places you put things in of different sorts into the model, you will find that most of the places you are specifying values. I mean, you can just go check it out here. You're specifying values here, specifying a value for the connection distance range. You're specifying values all throughout your system dynamics model. You're specifying values for parameters. It's just chock-a-block full of values. And when you specify those values, you sometimes do with literals. So going back to the beginning of this, you sometimes do with literals, but sometimes you do with things that calculate values. They are formulas. We call them expressions. So, here's the initial value, right? Here's the formula which computes what? It computes a value. Over time, it's computing a value for this flow. So we are chock-a-block full of values. Here's a condition that evaluates to a value to determine whether or not the condition should be triggered. Even in the midst of statements, these are chock-a-block full of values. A value is stored in this variable. We are setting this to be one value, determining another value for it. We are determining if I is less than that, which is an expression that determines a true or false, whether to continue the loop. So throughout our model, we are full of values. And that is the most common way you interact with Java, is by specifying values. Those values are sometimes numbers, sometimes they are strings, sometimes they are long expressions to compute those things. Comfortable with that? Okay, should we go into statements? People comfortable with that? Okay, let's talk about statements, the other side of the equation. Any questions? Okay, so let's talk about Java statements. Here we go. Ready? Okay, basics of Java statements. Maybe I should stop my recording here, and I'll